Here we'll start looking at even and odd functions and exactly how they're affected with integrals. So we'll start with a refresher of exactly what even and odd functions are. So let's start with even. There are two ways to define an even function. One is algebraically, one is geometrically. So algebraically, an even function is anything where f of negative x is equal to f of x. Geometrically, it has symmetry with respect to the y-axis. So the y-axis acts like a mirror. It looks exactly the same on the left and the right side of a y-axis. And if we have an even function, then the integral from negative a to a of f of x dx is equal to 2 times the integral from 0 to a of f of x dx. This is a trick that only works in very specific cases. In particular, your bounds have to be opposites of one another. You have to have an a and a negative a, and your function needs to be even. And then we can do this 2 times the integral from 0 to a. This can be helpful because it's usually easier to evaluate a function at 0 than any other number. So instead of having two more complicated numbers, we can have an easy number and one more complicated number. Now let's look at odd functions. Just like with even functions, there are two ways to define odd functions. Algebraically, f of negative x is equal to negative f of x. And the symmetry here is with respect to the origin. Essentially what this means is if I have a graph and I pick up my piece of paper and rotate it 180 degrees so it's upside down, I still have the same graph. And in general, if you have an odd function, the integral from negative a to a of f of x dx is just 0. So I'm not specifically explaining why these rules for integration for even and odd functions works, but I highly encourage you to think of some basic even and odd functions like x squared or x cubed. Think of a very basic number for a, maybe 2 and negative 2, and draw the pictures and see if you can figure it out on your own. See if you can figure out exactly why the odd functions will always be 0 and the even functions are always double the integral from 0 to a. Now that we have these rules, let's look at a couple of examples. Here I have the integral from negative 4 to 4 of x to the 7th minus 14x to the 6th plus 12x cubed plus 3x squared minus 4 dx. And we want to figure out exactly what this integral is using those tricks. Well, if I look at the entire function as a whole, it's neither even nor odd, but I can look at it individually. X to the 7th is an odd function, so it's going to go towards 0. The same thing with x cubed. In general, with polynomials, as long as your exponent is even or odd, that tells you whether that polynomial is even or odd. 6, 3, and in the case of 4, an exponent of 0, are all even. So these are now 2 times the integral from 0 to 4 of negative 14x to the 6th plus 3x squared minus 4 dx. So I have already simplified this problem. When I integrate, I add 1 to the exponent and divide. Same thing here, 1 to the exponent and divide. And the integral of 4 is just 4x. We're taking this between 0 and 4. So this is negative 2 times 4 to the 7th plus 4 cubed minus 4 times 4 minus sticking in 0, which is just 0. So this is why it's really nice for even functions, because a lot of times that 0 is very easy to evaluate. And once we do this arithmetic, we get an answer of negative 32,720. Let's look at another example. Here I have the integral between negative pi over 2 and pi over 2 of 3 cosine x plus 7 sine x minus 2 sine x cosine x dx. Well, let's think about the even and odd here. We don't really have exponents, but we can think of the graphs. And if you know what the graph of cosine looks like, you know that it's symmetric with respect to the y-axis. So it's going to be even. Sine, on the other hand, is an odd function because it's symmetric with respect to the origin. so that's 0. I now have 2 times the integral from 0 to pi over 2 of 3 cosine x. But what about this sine x cosine x? Is that even or odd? Well, in order to do that, let's look at it a little more in depth. We know that sine of x is odd and cosine of x is even. An odd function means that f of negative x is equal to negative f of x. And an even function means that f of negative x is equal to f of x. So, let's think of something, g to the negative x, which is sine times cosine. Well, sine is odd and cosine is even, so we can see that we have this extra negative sign floating around, so this must be an odd function. We can now go back to this and realize that this is 0. 2 times 3 is 6, and the integral of cosine is sine between 0 and pi over 2. I now have 6 of sine of pi over 2 minus 6 sine of 0. Sine of pi over 2 is 1, so 6 times 1 is 6, and sine of 0 is 0. So our answer is 6.